At this point, you should be getting comfortable constructing derivations with reiteration and the basic introduction and elimination rules. Now I'm going to introduce a bunch of new rules, but don't panic. The SD plus rules are meant to make solving derivation problems much easier. The SD plus rules are not actually adding anything new or more complicated to our derivation system. These rules are all shortcuts for valid arguments that can be proven with the original 11 rules. If you really love logic or find yourself incredibly bored with nothing else to do, you could do derivations to prove each of these. There are two categories of SD plus rules: the rules of inference and the rules of replacement. Let's start with the rules of inference. The three rules of inference work exactly the same way as the SD non-subderivation rules. They require input sentences with a specific structure and tell you what output you can derive. The first rule is modus tollens. In a way, this rule is the opposite of conditional elimination. You have the whole conditional on a line, and then you have the negation of the consequent on another line. This rule allows you to derive the negation of the antecedent. This rule is truth-preserving because if we know a conditional is true and we know the consequent is false, then we know the antecedent must also be false. If the antecedent were true when the consequent is false, the conditional would have been false in the first place. The next rule is disjunctive syllogism. If we have a disjunction and then we have the negation of one of the disjuncts, we can get the other disjunct on a line by itself. This is because we know that if a disjunction is true, at least one of the disjuncts must be true. So when we independently find out that one of the disjuncts is false, we can say that the other disjunct is true. The last rule of inference is hypothetical syllogism. For hypothetical syllogism, you need two conditionals in which the consequent of one is the same as the antecedent of the other. Hypothetical syllogism allows you to write down a new conditional that cuts out the matching sentence. So the antecedent of the first is the antecedent in the new sentence, and the consequent of the second is the consequent in the new sentence. You can do a really simple derivation using conditional introduction to prove that this rule is valid. So now let's talk about the rules of replacement. The rules of replacement are incredibly useful and they make derivations so much easier, but they are a bit different than the rules we've looked at so far. The rules of replacement give you pairs of logically equivalent sentences. In derivations, you can replace a sentence from a previous line with another sentence that is logically equivalent. The biggest difference between the rules of replacement and all of the inference rules, including the SD rules, is that they can be used on parts of complex sentences. You don't have to worry about having the sentence you're changing by itself, or you don't have to make sure about having a specific main connective. Let's go through the rules and then I'll show you how to use them with some examples. First, let's look at the rules of replacement that can be used on any sentence. The first is double negation. This rule allows you to add two negations to the front of any sentence. It also allows you to get rid of them when you have two negations stacked together on a sentence. This works because, in a sense, two negations cancel each other out. The first one tells you that sentence is false, and then the second one flips it back to true. Be careful when you use this rule that the two negations are actually attached one right after the other on the same sentence. If you have negations, say, separated by parentheses, you cannot use this rule to get rid of them. The other rule that can be used on any sentence is idempotence. This rule allows you to turn a single sentence into a conjunction or a disjunction where the other part is that same sentence again. This rule may seem silly, and you may not want to use it often, but it's still a good one to have in some cases. Now let's look at rules involving conjunctions and disjunctions. The first rule is commutation. This rule allows you to change the order of the conjuncts or disjuncts in a sentence. These are obviously logically equivalent, And the ability to rearrange sentences without trying to figure out how to take them apart, especially for disjunctions, is incredibly useful. The next rule is similar. Association allows you to move around parentheses when you have a complex sentence that is a series of conjunctions or a series of disjunctions. Be sure to remember that for this rule, you must have all conjunctions or all disjunctions. Things are a little more complicated if you have a combination of disjunctions and conjunctions, which brings us to the next rule. When you have a sentence with a conjunction as the main connective and a disjunction as one of those conjuncts, you can distribute that conjunction with the rule distribution. You'll now have a sentence with a disjunction as the main connective, and the conjunction and that original other conjunct will be inside each disjunction. As you can see on the second line here, this also works to distribute a disjunction across a conjunction. This rule is incredibly useful, but be careful to look at your rule sheet when you try to use it to make sure you have the right connectives in the correct places. You don't want to accidentally have all conjunctions when you're distributing across a disjunction. The last rule on this row gives us the relationship between negations and conjunctions and disjunctions. This rule is called De Morgan. The equivalence pairs here should seem familiar to you from back when we were learning to symbolize. The first pair symbolizes not both, a negation outside of a conjunction or a disjunction with negations on both disjuncts. The second pair symbolize neither nor, a negation outside of a disjunction or a conjunction with negations on both conjuncts. One way to think about this rule is that you move the negation into parentheses and it puts the negation on both of the parts and flips the symbol, either from a disjunction to a conjunction or from a conjunction to a disjunction. You can also move it back, right? You can flip the symbol and bring that negation outside if you have a negation on both in a conjunction or on a disjunction. This is my favorite rule of replacement. I can't even tell you how useful it is in so many cases. So this is a really great one to be familiar with and start practicing with. Now let's move on to the rules of replacement involving conditionals. The first is implication. This allows you to turn a conditional into a disjunction with a negation on the first disjunct, which was the antecedent in the conditional. This works because of the truth conditions of a conditional. A conditional is only false if the antecedent is true and the consequent is false. So if the conditional is true, then we know either the antecedent is false or the consequent is true. The next rule is transposition. This rule allows you to reverse the order of a conditional. The negation of the consequent becomes the antecedent, and the negation of the antecedent becomes the consequent in the new sentence. This rule is valid for the same reasons that modus tollens, the rule of inference, is valid. If the consequent of the original conditional is false, then we know the antecedent must also be false. The last rule on this row is exportation. Exportation allows you to go from a conditional that has another conditional as its consequent to a conditional that takes both of those antecedents as the one antecedent in a conjunction. You should easily be able to prove this rule, these sentences are equivalent, using truth tables or a derivation. Because if you look at the first sentence, if you have both the true P, then you get the second conditional, and then if you also have a true Q, you get the R. So that proves the other side. The last rule of replacement involves biconditionals. Equivalence tells you that a biconditional can replace or be replaced by a pair of conditionals that show the conditional relationship goes both ways. So in this case, you'll have if P then Q and if Q then P. This should obviously be valid based on the definition of a biconditional, right? If and only if. Here you have that if statement and that only if statement. The second line shows that a biconditional can also be replaced by or replace a disjunction that says, either both P and Q or not P and not Q. This sentence demonstrates the truth conditions for a biconditional. The biconditional is true if the truth value of its parts match. So either they're both true or they're both false. I know this may feel overwhelming since there are a lot of new rules, especially the rules of replacement. I want you to remember that you do not have to memorize them. You can and should always have the rule sheet handy when doing derivations, especially on the exam. You technically don't even have to use the SD plus rules. All of the derivations can be done with just the original 11. But getting comfortable using the shortcut rules will make doing most derivations much easier. Now let's look at some example problems. This problem, done with just the SD rules, just the basic 11, is very long and involves multiple subderivations inside one another. But let's look at doing it with the SD plus rules. So here we're trying to derive not D, and our premises are if D then E, if E then Z and W, and either tilde Z or tilde W. So the first thing we're going to do is look at that third premise and see how it relates to the second, right? So we have Z and W, and then we have it's either not the case that Z or it's not the case that W. So we know the consequent of that second premise is false, but we have to show that, right? We have to get it in the same form. So in line 4, we're going to use De Morgan's, the rule that shows the equivalence between negations and conjunctions and disjunctions, to move that negation out and put that sentence in parentheses, and we flip that disjunction to a conjunction. So now we have the negation of the consequent of the conditional on line 2, which means on line 5, we can use modus tollens, right? We have the negation of the consequent, so we can get the negation of the antecedent. And now we have tilde E, right? It's not the case that E on line 5. And on line 1, we have if D then E. So again, we're in the situation where we have the negation of the consequent of a conditional. So we can use modus tollens again and get tilde D, right? It's not the case that D on line 6. So this problem goes from taking 15 lines plus and several subderivations to just being a 3-line argument. So this is why getting comfortable with these rules is so important. We're going to look at 2 more problems. Let's look at the next one. Here we have if A, then if C, then B. We have if not C, then not A. And we have A. There are a couple of ways that we can do this problem with the shortcut rules, with the rules of replacement. You may do it a little bit differently than I do, and that's absolutely fine. So the first thing I'm going to do here is look at the sentences that I have, right? I have A, and then I have it's not the case that A as the consequent of the conditional on line 2. So we already see that I have the opposite of that consequent. And here's one thing you need to make sure you pay attention to. For modus tollens, right, the rule that we could use here, you have to have the negation of that consequent for it to work. So what we have to do on line 4 before we can use modus tollens is use double negation on A from line 3. Now we have it's not the case that A. This allows us to use modus tollens on line 5 to get the negation of the antecedent. So now we have 2 negations on C. It's really important to pay attention to double negations here. If you had gone straight from 2 to 3 with modus tollens, that would have been a mistake. You have to have the negation of the consequent, even if that's a negated sentence. But thankfully with double negation, that's really easy to get. So now on line 6, we can use double negation again and take those two negations off C from 5. Now on line 7, I'm going to put A and C together in a conjunction using conjunction introduction. And I want to do this because when I look at 1, I have if A, then if C, then B, which if you remember our rules for conditionals, we know we have exportation, which allows us to turn that into if A and C, then B. So now we have the antecedent and that conditional. So on line 9, we can get B via good old conditional elimination. And that's finishing this proof, right? We've used several of those rules of replacement and the inference rule modus tollens to get there. Let's look at one more problem. This problem is let's look at another problem. This problem, we're trying to derive J, if J, then M or, in parentheses, G or I, right? So here we've got a lot of different things going on inside of series of disjunctions. So the consequent of line 1 looks very, very similar to that antecedent of line 2. Right, so we're thinking that we might want to use hypothetical syllogism, right, which will let us replace that. But when we look closer, we see that those sentences aren't the same, right? We have K or L or H, and then in the second one, we have K or L or H, right, with those parentheses. So first we need to use association on line 1 to move those parentheses from around L or H to around K or L. And now we have it lined up where the antecedent of line 2 is the same as the consequent of line 3. So now we can switch those together, right? We can use hypothetical syllogism and get J or M or G or I. But importantly, this doesn't look the same as the conclusion we're trying to get yet, right? Details are really important with derivations. What we need is M or G or I with the parentheses around the G or I. So we can use association again to get that. And it's important here that you have to do these steps one at a time. You can't use association twice on the same line. You can't blend these together, right? You have to use each of these replacement rules separately. And notice that we did use association inside other sentences, right? We did it on the sentence that was the consequent of that sentence. So this is what I meant by being able to use those association rules inside other sentences. Let's look at one more problem. This problem is quite a bit more complicated than anything we're going to ask you to do on the exam in this class. But let's look at it because I want you to see how you can kind of work these things out. So what we're trying to get is if it's not the case that A, then if B, then G or D. We have all of those parts in these sentences, and we have to try to figure out how to get them together. So the first thing I'm going to do is looking at A or B here, right? I want to try to change that into something that I can use. So I'm going to put a double negation on A, right? You can use a double negation on any sentence, including on a part inside of a sentence. So now we have, if it's not the case that it's not the case that A, or it's not the case that B, or it's not the case that C. And the reason I want to add that double negation is because I need to get a negation on the A, and I also want to get it's not the case that A out of a disjunct. So on line 4, I'm going to use De Morgan's on that side of the disjunct, right? That side of that main disjunction to get it's not the case that not A and B. And now I have a negation on the first part of a disjunction. So I can use implication and turn this into a conditional, right? We drop that negation from in front of the first disjunct and turn that into our antecedent, and then the other disjunct becomes our consequent. Remember, you have to have a negation on that first part that then drops off when you turn it into a conditional. So now I'm going to turn my attention to that second premise, right? Because we're trying to get G or D by itself. Right now we have C in the middle, so let's work on that one. So I'm going to start by using commutation to switch around the order of the disjuncts. And we're using it on this main disjunction, right? The one that connects it with C. So now we've swapped C with D or G. Now to get G or D in the order that we want for our conclusion, we have to swap it around with commutation again. You can't do these two steps at once. This time we're doing commutation on this disjunction inside the parentheses to swap that around. Now I'm going to do the same thing that I did before to try to get a conditional sentence, right? I'm going to add double negations on C. Now I have a negation I have a negation on my first disjunct, and I have on my first disjunct of a disjunction. So I'm going to do the same thing again, and I'm going to use implication. For implication, I remove a negation from that first disjunction and turn it into my antecedent, and then the other disjunct is my consequent. Now, if you look at line 5 and you look at line 9, we have it's not the case that if it's not the case that A and B, then not C, right? I have not C as my consequent, and on line 9, I have not C as my antecedent. So on line 10, I can use hypothetical syllogism and cut out the not C from both of those. So I can have, if it's not the case that A and B, then G or D. And now we can use the rule of exportation. Remember, exportation allows you to have, when you have a conjunction as your antecedent, you can turn that into a complex sentence with another conditional. So by exportation, I can turn I can turn if it's not the case that A and B, then G or D into if it's not the case that A, then if it's not the case that B, then G or D. I'm not sure this problem was as clear to you as I was hoping to make it, but I did want you to see, especially with using commutation, that you have to take these one step at a time and that you can use multiple of these rules. The textbook also goes over this problem. So if you have any concerns or this explanation was unclear, which I feel like it might have been, I do recommend you go do that reading in the logic book. The logic book goes over these rules from page 214 to page 222. They're also mentioned in course manual lesson 4, and the strategies for derivation document I will always be recommending to you while we're working on derivations, right? It's incredibly helpful. So that's it for this video. I know this video is quite a bit longer than I tried to make them, but there's a lot of SD plus rules. One consolation is that this is the last of the new material for this section. We're just doing practice from here on out until we do the exam and move on to the next section of the course.